This is the largest helicopter in the American military. It has over 400,000 individual parts. And before a single engine turns over, every one of them has to work perfectly. The Marine Corps is betting everything on this aircraft today to recover a downed fighter jet in enemy territory. In a Pacific war with no bases and no runways, this is the only helicopter that can do it. But before any of that matters, the crew has to pull off one of the most dangerous engine starts in the world on a ship deck in open ocean with 7 rotor blades the length of school buses unfolding overhead. A crew chief has already walked every inch of the airframe. Nothing has become a problem. Yet, once this walk-around is done, you usually start the engines. On the King Stallion, you're not even close. Before anything can turn over, 7 rotor blades that have been folded flat against the fuselage for storage have to unfold, swing outward, and lock into their flight positions. Each blade is 40 feet long, roughly the length of a school bus, mechanically unfolding on a ship deck that is rocking in open ocean while other aircraft and personnel are parked within the rotor arc. The automatic blade spread system handles the sequencing, but automatic doesn't mean casual. If a blade fails to lock, the start stops. If the indexing is off by a fraction of a degree, the vibration at full rotor speed would shake the aircraft apart. Every single blade has to report locked and aligned before the crew chief will even think about fuel. Now the start sequence begins, but not with the engines you'd expect. You can't just fire up a King Stallion. You have to start a smaller engine first, whose only job on this Earth is to wake up the bigger ones. This is the auxiliary power unit, and without it, 3 General Electric T408 turboshaft engines producing 7,500 horsepower each are just expensive lawn ornaments. The APU spools up, feeds electrical power and air to engine number 1. And now the crew chief is watching the exhaust gas temperature gauge like it owes him money. And right now, it looks like he might not get paid back. Each engine is managed by dual redundant FADEC computers, full authority digital engine control. On a mechanical helicopter, the pilot controls fuel flow directly through a cable connected to the engine. Mess up the throttle and the engine tells you immediately. On the King Stallion, the FADEC decides how much fuel the engine actually gets based on dozens of inputs: air temperature, power demand, the state of the other 2 engines. The pilot requests power, the computer decides whether to grant it. Each engine lights one at a time. Firing all 3 simultaneously would overload the electrical system and risk a compressor stall. What happens when the engine chokes on its own airflow and sends a pressure wave backward through the intake hard enough to shatter turbine blades? So you bring them online one by one, and you don't look away from the gauges. Run too hot and temperatures spike past the red line. Internal components start to deform. And if nobody catches it in time, a multi-million-dollar engine just became an oversized paperweight. Run too cold, and the ignition doesn't fully catch, which means shutting everything down, purging unburnt fuel, and starting the whole sequence over, all while potentially under enemy fire. And on most helicopters, that's the hard part. Once the engines stabilize, you're more or less in the clear. Not here. The CH-53K has 3 engines crammed together in a fuselage that's only slightly wider than its predecessor. And during testing, engineers discovered something alarming. The rotor downwash was pushing hot exhaust gases down from the engines, swirling them under the fuselage and feeding them right back into the engine inlets. The helicopter was trying to breathe its own exhaust. They call it exhaust gas reingestion, and it causes the exact kind of compressor stalls that the crew is watching for during every start. The problem was severe enough that Sikorsky and the Navy put together a special team that evaluated 135 different design fixes and burned 30 million hours of supercomputer time modeling airflow around the fuselage before they found a solution: lengthening the exhaust ducts and redesigning the airflow path so the hot gas gets pushed away from the intakes instead of recirculating back into them. The fix works, but the margins on this aircraft are not generous, which is why the crew chief watches those gauges the way he does. 1 engine stabilizes, then 2, then 3. The rotor heads start to turn. The King Stallion's rotor disc is 79 feet across. On a deck where other aircraft, fuel lines, ordnance, and personnel are all within that radius, every position is planned to the foot. crew members wear cranial helmets and float coats because this helicopter doesn't care who you are or where you're planning to stand. It'll send you over the side regardless. The helicopter lifts off the deck and banks west. Everything that just happened was the easy part, because what's waiting on an island 100 miles from here is the reason the Marine Corps spent $25 billion on this aircraft. An F-35B Lightning II went down hard on a remote forward strip. The gear collapsed on touchdown. The airframe is intact. Stealth coatings, avionics, weapon systems, all of it sitting in the open, on an unsecured strip with a clock ticking on how long before the wrong people reach it. In an earlier era, the math here is ugly. Either disassemble the jet piece by piece and hope a road exists to truck it out, or destroy it in place to keep a generation of classified technology out of enemy hands. Torching a $100 million aircraft because you can't pick it up is the kind of decision that ends careers and starts congressional hearings. The CH-53K is the only helicopter suited for the job, with its cargo rated for 36,000 pounds on its external cargo hook. That's the same as 3 fully loaded school buses hanging from a single point, or just one F-35B. Meanwhile, on the ground, rigging crews are working fast. A 4-point sling attachment distributes the jet's weight across the airframe, and every connection has to be balanced within tolerances that would make a surgeon nervous. One attachment point carrying more load than its opposite, and the helicopter becomes uncontrollable the instant it takes the weight. Every strap rated well beyond the expected load. Every shackle inspected, re-inspected, and signed off. Because once this jet leaves the ground, the only thing between it and a very expensive crater is a steel hook and the crew's judgment. The King Stallion moves into a hover over the jet, and this is where the helicopter does something no other heavy lifter in the world can do. The pilot can't see the F-35 below. A crew chief lying on the cargo ramp, head hanging over the edge, talks the aircraft into position. Forward 10, right 5, hold, steady. A 74-foot helicopter being placed directly over a jet the crew can't see, guided entirely by voice. On the old CH-53E Super Stallion, the hover like this would have had the pilot fighting the controls with both hands, physically wrestling mechanical linkages connected by cables and push rods to the rotor head. Pilots used to finish long missions with bruised hands and wrecked shoulders, and that was without 36,000 pounds on the hook. The King Stallion doesn't work that way. There's not a single mechanical connection between the pilot's stick and the rotor. None. When the pilot moves the cyclic, an electrical signal travels to 3 independent flight control computers, and those computers command hydraulic actuators to move the blades. The pilot makes a suggestion. The computers decide how to execute it. And between each of the crew chief's voice commands, between forward 10 and right 5, those 3 computers are making hundreds of corrections per second that the pilot never asked for and never feels. Compensating for wind, adjusting for the rotor wash bouncing off the F-35 surfaces below, counteracting the micro shifts in a 44,000-pound helicopter hovering in ground effect over an object it absolutely cannot bump into. If one computer disagrees with the other 2, it gets voted out instantly. If 2 fail, the 3rd flies alone. The pilot's job is to listen to his crew chief and manage the big picture. The computers handle everything in between. The hook finally connects. Slack comes out of the slings. The pilot pulls power, and 36,000 pounds transfers through a transmission that was designed from a blank page for exactly this moment. The old CH-53E's gearbox was the component that limited everything: flight hours, life capacity, service life. Sikorsky threw it away and started over because the Marines told them to build a helicopter that could carry an F-35, and the engineers worked backward from that number. The helicopter climbs out with the jet swaying beneath it like a pendulum the size of a city bus. Airspeed limited. Route planned to avoid ridge lines and turbulence. Every gust magnified by the physics of a long cable and a heavy, flat object catching wind at the end of it. The fly-by-wire system absorbs all of it. This is exactly what those computers were designed for, and the rotor spinning overhead is handling stresses that would compromise a conventional helicopter. 7 blades, not one of them metal. Carbon fiber and advanced polymers layered so that if a 23mm anti-aircraft round punches through one, and in this airspace, that's not a hypothetical, the blade flexes around the damage and keeps turning. A metal blade cracks, and the crack races through the structure until the blade comes apart. Composite doesn't propagate the fracture. The fibers around the impact absorb the load from the ones that just got shattered, and the pilot might not know he even took a round until maintenance finds the hole after landing. And if one of those 3 engines takes a hit, or simply quits on its own, the FADEC computers redistribute power across the remaining 2 without the pilot touching a single control. Full load still on the hook, full flight capability. The aircraft just got lighter on power and kept flying. The F-35 makes it back to the ship, but recovering broken jets is the mission people know about. What happens next will transform a bare island into a core base in less time than it takes to have a pizza delivered. A Forward Arming and Refueling Point, or FARP, is a pop-up gas station built on dirt. Fuel bladders, hoses, hand pumps, and a team of Marines who can have the whole thing running in under an hour. No concrete pad, no permanent infrastructure, just rubber and ingenuity on whatever flat ground is available. The problem is getting fuel there in the first place. The MV-22 Osprey, the tilt rotor that's been sprinting troops to this island at twice the speed of any helicopter, tops out at around 20,000 pounds of external cargo. It's fast, but not strong enough to carry the heavy fuel bladders, the pumping equipment, or the vehicles the Marines need on the ground. The Osprey got the people there. The King Stallion brings everything those people need to stay. It arrives with a massive rubber fuel bladder slung beneath it, sets down, ground crew disconnects the load, the helicopter heads back for more. And within the hour, the FARP is pumping JP-8 into every aircraft in the area that needs it. Here's why this matters beyond the obvious of gas means go. In a Pacific conflict, every fixed air base within range is a target. Runways, fuel farms, maintenance hangars. These will be hit with ballistic missiles before most people even know a war has started. The bases America has operated from for decades will become craters in the opening hours. FARPs are the workaround. Dozens of tiny, temporary fuel points scattered across islands and coastlines, none of them in the same place long enough to be worth a missile. The King Stallion is the only thing that can build them, and the only thing that can move them when it's time to disappear. And moving is not optional. A FARP that stays put is a FARP that gets found. When aircraft start landing for fuel, rotors turning, engines running, fuel flowing through hoses on unprepared ground, the signature is enormous. Grounding cables go down first because a helicopter builds up static charge in flight, and one spark near JP-8 vapor turns your hidden fuel point into a signal flare visible for 20 miles. The refueling happens fast. The noise alone is disorienting. Rotor wash from a helicopter that hasn't shut down is flattening everything within 80 feet, while Marines in goggles and gloves are wrestling fuel hoses across uneven ground. Sand and debris are moving horizontally. The hose connections are stabilized, but the terrain isn't. A fuel bladder sitting on coral doesn't behave like one on a concrete pad. Every connection gets checked by feel as much as sight, because visibility under a running King Stallion is a suggestion, not a guarantee. Aircraft in, topped off, out. And when the window closes, the King Stallion hooks the bladders, picks up the equipment, and the entire operation relocates to a new patch of ground 30 miles away. And by the time anyone investigates the old site, there's nothing there but boot prints. But getting the gas forward was just part of the problem. 40 miles south, there's a Marine artillery battery with no way to reach its target, unless someone picks up a 9,000-pound howitzer and puts it on a hilltop before the enemy notices. A Marine tactical drone circling at 15,000 feet has picked up an enemy staging area, vehicles and equipment marshalling in the open. The imagery feeds to a command post and the fire mission goes out. There's just one small problem though. The nearest artillery battery is at the staging base 40 miles south. The roads between here and there, assuming they exist, are not friendly. Driving a howitzer into range would take hours and announce exactly where you're going the entire way. There's one option that gets a gun into position before that staging area disperses. Pick it up. The King Stallion's external cargo system isn't a single hook, it's 3. A single point hook, a tandem pair, and a fore and aft configuration, each one purpose-built for different load geometry. The F-35 needed a single point center of mass lift. The howitzer needs something different. The King Stallion hooks an M777 howitzer on the external cargo system, 9,300 pounds of titanium artillery plus a pallet of 155mm rounds. The gun crew rides in the cabin, pick up to firing position on a pre-surveyed hilltop, under 40 minutes. But they're not sitting idle during the flight. The section chief has the target coordinates on a tablet fed by the drone's live downlink. He's computing firing data in the air, elevation, charge, deflection, so the crew can lay the gun within minutes of touching dirt instead of starting the math from scratch on the hilltop. By the time the King Stallion flares over the firing position, the crew already knows the azimuth, already knows the range, already has rounds shorted by charge. The wheels hit the ground and they're moving before the rotor wash settles. Every second on that hilltop is a second the enemy has to find them. The howitzer is unhooked, set, and the crew lays the gun using coordinates the drone is updating in real time. First round is downrange within minutes. The drone confirms effects on target, rounds adjusting, and now the clock that matters most starts running, because counter-battery radar just traced those outgoing rounds back to this hilltop. The enemy knows where the fire is coming from. Return fire is being calculated right now. The gun crew has minutes to spare. The King Stallion, which has been holding nearby, comes back in low. The crew hooks the M777. The helicopter lifts and heads for the next position 8 miles east. Behind them, enemy rounds hammer the hilltop they just left. Craters in the dirt. The gun is already gone. This is what the Marine Corps calls shoot and scoot pushed to the extreme. Instead of a truck hauling a howitzer down a road that might have an ambush or a mine waiting on it, the King Stallion lifts the entire firing position over the terrain. The gun can appear on any hilltop, any ridgeline, any clearing within range, fire for effect, and disappear before the response lands. And with the FARP that this same helicopter built 2 hours ago, it can refuel and run the whole sequence again from a completely different position. Bye for now.